Okay, solving quadratic equations using factors. Here is our first full example. Example 1. Solve the equation 5x squared minus 15x equals 0. So the first step is we simplify if we can. And if you look here, there's no brackets to be multiplied, so it is already simplified. The next step is we make it equal 0, or we make sure that our equation equals 0. But as you can see, our equation does equal 0. So we're into the third step, which is to use factors. Now to use factors, what we do is we look at the left-hand side here, and you can cover the equal 0 for a second and ask yourself, what type of quadratic is this? Is it a HCF? Is it a difference of two squares? Or is it a trinomial? Well, it can't be a trinomial because it doesn't have three terms. Let's see if it has a highest common factor. Is there any number or any letter that these guys have in common? Well, the answer is yes, they do. So it's a HCF type. So we can write down our HCF is 5x. And what we do is we use our knowledge of factors. We're going to factorize this using the HCF. So we take the HCF out, which is 5x, bracket, and the only difference is we have an equal 0 attached to the end. Well, what's left inside the bracket? 5x by something gives you 5x squared. Well, the answer here is x minus 3. And we can double check. What's a 5x by an x? It's 5x squared. And a 5x by a minus 3 is a minus 15x. So what we have done is we took a sum that was a takeaway sum equals 0 and we turned it into a multiply sum equals 0. And here's our big idea again. Because we've got two things, 5x is one of them and x minus 3 is the other, because two things multiplied gives you 0, we are able to separate the sum into two separate sums. We're able to say that 5x is equal to 0 or x minus 3 is equal to 0. So this is a big moment because we've changed this one sum into two separate sums. We solve both these sums separately and then we get our answers. So on the left, we've got 5x equals 0. And notice this has no x squared in it. It's just a linear equation. 5x equals 0. So x is equal to the opposite of multiplying by 5 is dividing. 0 divided by 5, which of course you guys know is 0. So there's one answer. Over here, we want to get x on its own. So we leave the x on the left. And when you bring the minus 3 over to the right, it's plus 3. So we get x equals 3. And they are our two answers. We've got two answers for this sum. X equals 0 and x equals 3. And these numbers are called roots of the equation. If we wanted to check our answers, we could sub in 0 back in here and see if it works. 5 times 0 squared minus 15 times 0 on a calculator or in your head, and it would work out to be 0. And if you put a 3 in, 5 times 3 to be squared minus 15 times 3, well, 3 squared would be 9, 9 5s are 45, and 15 times 3 would be 45. So you get 45, take away 45, which is 0, so it will work. Next one, solve x squared equals 9. Well, first of all, we simplify if possible, and there's nothing to simplify here. Next step, we make it equal to 0, and as we can see, it's not equal to 0. So how do I get rid of that 9? By bringing it over to the left-hand side. When you bring a plus 9 over to the left, it becomes a minus 9 equals 0. So now I have it equal to 0. Then I cover my equal 0 and I ask myself, what type of quadratic is this? Is it a HCF? Do they have anything in common? No. Is it a trinomial? No. Is it a difference of two squares? Well, let's see. To see if it's a difference of two squares, if I can rewrite it as a square minus a square equals 0, well then it is a difference of two squares. And as you can see, I can put an x here and the number 3 here. So it is a difference of two squares. But remember, I'm not finished. To finish off a difference of two squares, I put x minus 3 in one bracket, bracket x plus 3 in the other, and I have an equals 0 now as well. Now I have changed the sum into a sum where there's something multiplied by something equals 0. Our big idea. Something multiplied by something gives you 0. So we can separate it into two sums. We can say x minus 3 will be 0, or x plus 3 could be 0. And these two equations we can solve very easily. This one here, x, when I bring the minus 3 over, it becomes 3. And this one, x is, when you bring the 3 over, it becomes a minus 3. So my answers here for this one are x equals 3 and x equals minus 3. And notice I have 2 roots again. These are roots of this equation. And if you want to test your answer, well, let's try 3. 3 squared, what would 3 squared give you? 3 squared would give you 9. It works. What about minus 3 though? People always forget about the minus 3. Well, minus 3 to be squared would be 9. Let's say minus by minus is a plus. 3 3s are 9. So this also works. So that's our second example. I have a third example on this video. Example 3. Here is another quadratic. It's a quadratic because it has an x squared and it has an equals quadratic equation. We simplify if possible. We cannot simplify this anymore. We make sure it's equal to 0. This is equal to 0. So we're straight into looking at this. Is this a HCF? No. Is it a difference of 2 squares? No. Is it a trinomial? Yes. And again, you might have to revise over the chapter that we did on factorizing. The method I use is the so-called x factor method. Remember, we do this and we put an x here and an x here because x by x is x squared. The positive 6 at the end means the signs are the same, and because the middle guy is a negative, they're both going to be minuses, so the signs are both the same and are minus. Factors of 6 are 6 by 1, 2 by 3, and we're looking to find by trial and error which of these combinations will give us minus 5. And 2 and 3 I think might work. How the x factor works is you go x times minus 2 is minus 2x, and x times minus 3 is minus 3x, and just see what they add up to. They add up to minus 5x, which matches the middle. So I have it right. So how I read my answer off is, or well, not my answer, my factors, is I end up with x minus 2 in one bracket times x minus 3 in the other equals 0. And again, here's our big idea again. We've got something multiplied by something equals 0. So because we've got two things multiplied gives you 0, we can separate it into x minus 2 equals 0, or x minus 3 equals 0. And again, we get two separate equations, which are linear simple equations. So this one, to solve this one, you bring the minus 2 over and you get x equals 2. And this one, you bring the minus 3 over and it becomes x equals 3. And those are the answers for this equation. These are our roots of this equation. There are plenty of examples like this in your textbook and questions to practice on as well.